Greetings, everyone. Greetings wherever you're seeing me from. I welcome us back to our class on Maths 112. Today we are on our lesson 2. If you have not watched the video of the lesson 1, please, I will advise you to go do that because the lesson 1 is the basic foundation to every other thing we'll be doing. And remember, if you still have questions on the lesson 1, let me see your question on the comment section. Okay, today is lesson 2, and in our lesson 2, we shall be differentiating some functions. I will be differentiating trigonometric function. I'll be differentiating exponential functions. I'll be differentiating logarithm functions. Okay, so I'm going to take them in cases. The case 1, I'm going to be taking differentiation of trigonometry functions, like you can see on the board. Okay, in this case now, what you can see on the board, we have functions and their derivatives. When you come to trigonometric functions, you should know that sine and cos are kind of fundamental in this function, meaning that every other trig function has a way they combine either sine only or cos only, or their combination of sine and cos. Hence, anytime we want to differentiate any trig function, we must first of all evaluate or find out their combination of either sine or cos or the both before we can proceed to differentiate that trig function. So on the board, we have, when you differentiate sine x, you have cos x. When you differentiate cos x, you have minus sine x. These two should be memorized because they are fundamental. Then coming to from number 3, we have tan x. Tan x is the same thing as sine x over cos x. That is how it combines this fundamental. And when you differentiate tan x, you have sec squared x, or 1 over cos squared x. The next one is sec x, or 1 over cos x, which when you differentiate it, you have sec x tan x. The same goes to number 5, and the same goes to number 6. Now, from number 4 to 6, some persons find it so difficult to have it up there, but look at this. Their equivalent of the fundamental, it is a function of their third alphabet in their spelling. Look at what I mean. This one is sec x. Spell 1, 2, 3. The third alphabet is what really determines how it combines sine or cos. So 1, 2, 3. The third alphabet here is cos, C. The only person starting with C here is cos. So we have 1 over cos x. 1, 2, 3. The third alphabet here is S. And this guy is the X guy. And that is why we have 1 over sine x. 1, 2, 3. The third alphabet here is T. So the only person carrying T is this tan. So this guy is also 1 over tan. But you know tan is sine over cos x. So, but upside down now because it's an inverse. So you have cos x go up over what? Sine x. And that is how we memorize or put these things up there. So in our case 1.1 now, I shall be differentiating from number 3 to number 6 to enable us to see how the whole of this were gotten by differentiating this. And we shall be applying the rules that we have learned in the lesson 1. That is why I said, if you have not gone to see the lesson 1 class, please go and see it. It is a fundamental to whatever we are going to be doing as far as this Maths 112 class is concerned. So let's move to case 1.1 now. Okay, we are seeing on the board case 1.1. In our case 1.1, we shall be seeing how to differentiate general trigonometric functions. We have on the board some example. For example, number 1, if they give us a y equals to tan x, y equals to sec x, y equals to cosec x, and y equals to cot x, we are asked to differentiate all these. Okay, so I shall be solving it this way. So let me take number 1. It says y equals to tan x. They asked me to find the y dx. Now, for me to be able to get the y dx here, like I said, you must be able to find the sine and cos transform for tan x. This is also the same thing as sine x over cos x. So I'm going to be saying it like this now. Now, if I'm saying it like this, the ruling algebraic sign here is division. So I'm going to be using the quotient rule, just like we learned in the lesson 1. So here I'm going to be having that my dy over dx will be v du dx minus u the v dx over v squared. Okay, so this case, this is my u and this is my v. Always remember that the one up is your u, the one down is your v. So I'm going to be having let u equals to sine x, then du over dx, because if you differentiate sine x, you have cos x. Then let v equals to cos x. If you differentiate cos x to have the v over the x, you are going to be having minus sine x. I believe this is really gotten. Now, I have my u, I have u, I have the u, I have v, I have the v. I'm going to arrange them this way because I'm using division rule. So, my dy over dx becomes v, what is my v? Cos x into du dx, du dx cos x minus u is sine x into dv dx, dv dx minus sine x all over v squared. Remember, v is cos x, so it's going to be cos squared x. So what we have on the board here is what we call v du minus u dv over v squared. At this point, we try to simplify. Cos times cos will give me cos squared x minus sine x times minus sine x will give us plus sine squared x all over cos squared x. Okay, at this point, let me clean this. At this point, we should know that sine squared x plus cos squared x will always give you 1. So this becomes cos squared x plus sine squared x is 1 over cos squared x. I believe we saw this in the table. So it means if I differentiate tan x, I'm going to be having cos squared x. If I differentiate tan x, I'm going to be having cos squared x. Remember that to simplify the answer more, if I have 1 over cos squared x, is the same thing as writing 1 over cos x times 1 over cos x. 1 over cos x times 1 over cos x. So, which is the same thing as 1 over cos x is sec x times sec x. 1 over cos x is sec x, 1 over cos x is sec x. Sec x times sec x will give me sec squared x. So also, if I differentiate tan x, I can also say I'm going to have sec squared x. So sec squared x and 1 over cos squared x are all derivative of tan x. That simplifies the first question. The second one is going to be sec x. We want to differentiate sec x now. Okay. The question says that y equals to sec x. We should find the y dx. Remember that the equivalent of sine sec x is 1 over cos x. So if I'm saying it this way, I can also use division rule. So my dy over the x here is v du dx minus u dv dx all over v squared. That is what is there. So at this point, my v, this is my u, this is my v. Let u equals to 1 so that the u over the x will give me 0. Let v equals to cos x so that the v over the x will give me minus sine x. So I'm going to arrange these things to look like this. I come over this side. So I'm going to be having my dy over the x should give me v, which is cos x, into du dx, du dx 0 minus v, u now, which is 1, into the v dx, the v dx minus sine x, all over v squared cos squared x. And this becomes cos x times 0 will give us 0. That one is off. Minus 1 times minus sine x will give me plus sine x. Hope you know that. Plus sine x all over cos squared x. Now, remember we splitted this in the case of tan. So we can move forward to say this is also the same thing as sine x over cos x times 1 over cos x. Why? Sine x times 1 is sine x. Cos x times cos x will give you cos squared x. Now, looking at this trig identities like this, sine x over cos x, remember, sine over cos is tan x. Why 1 over cos x is sec x times sec x. So if I multiply these two things together, I can have it as tan x sec x. So that when we differentiate sec x, we are going to be having tan x sec x according to what we have on that table. So that is number 2. We go to the next one. In the third one, we are to differentiate cosec x. They gave us that y is equals to cosec x. We should find the y dx. Now, if y is equals to cosec x, its equivalent is 1 over sine x. So if I'm seeing it as 1 over sine x, my dy over dx will be equals to v du over dx minus u dv over dx all over v squared. So at this point, let my u be equals to 1 so that my du over dx will give me 0. Then let my v be equals to sine x so that my dv over dx will give me, if you differentiate sine x, you have cos x. Now, moving on with this, I'm going to now arrange all these parameters this way. So my dy over dx finally becomes v, which is sine x, into du dx 0 minus u, which is 1, into dv dx cos x all over v squared sine squared x. I move over to this side. Remember that this time this will give us 0. Minus 1 times cos x will give us minus cos x. So we have minus cos x here over sine squared x. So the same thing will happen here. This is equivalent to minus cos x over sine x times 1 over sine x. So that minus cos x times 1 will give us minus cos x. Sine x times sine x will give us sine squared x. So at this junction, we are going to be having minus, you see, cos x over sine x is cot. Remember that sine over sine x over cos x is tan. Why cos x over tan sine x is cot. So this over this is cot. So remember there's a minus here. So it's going to give us minus cot x. Minus cot x. So I put it down there. Minus cot x times 1 over sine is cosec. Cosec x. If I multiply these two things together, I'm going to be having that my the y dx finally becomes minus cot x cosec x. Meaning that if I differentiate cosec x, I'm going to be having minus cot x cosec x. Remember the way we splitted this to come to this. So, and the last one we are going to be seeing here is cot x. Cot x. All these things we are doing is just to prove all we have on the table there. We are seeing cot x now. Okay. Y equals to cot x. They asked me to find the y dx. Remember that the equivalent of cot x in trig identity is cos x over sine x. Okay, so in this case, I will say let u equals to cos x, so that my du over dx becomes, if I differentiate cos x, I have minus sine x. Then let v equals to sine x. If I differentiate that and to get my dv, I'm going to be having, when I differentiate sine x, I have cos x. At this point, my dy over dx is still v du minus u, the v over v squared. So here, my v is sine x into du minus sine x minus my u is cos x into dv, which is also cos x, all over v sine squared x. So in this, at this junction, sine x times minus sine x will be giving me minus sine squared x. So there I'll be having, here I'll be having minus sine squared x, then minus cos x times cos x will also give me minus cos squared x, all over sine squared x. Now remember, in the earlier time, we have seen one trig identity that says sine squared x plus cos squared x is equals to 1. I believe you have written this down somewhere. Then this time around, minus sine squared x minus cos squared x should give you minus 1. Also keep this one somewhere. So having this in mind, minus sine squared x minus cos squared x will give me what? Minus 1 over what? Sine squared x. Minus 1 over what? Sine squared x. Remember that 1 over sine x is cosec x. Do you remember that? So 1 over sine squared x will give me cosec squared x. So 1 over sine squared x will give me cosec squared x. Remember there's a minus here, you put it. And that gives us that when we differentiate cot x, we have minus cosec squared x. Another way to move is this way, or from here now, sine square is an LCM to both of them, so I can have it to be sine squared minus sine squared x over minus sine squared x over sine squared x minus cos squared x over sine squared x. I believe you understand this. We splitted it. Based on this is the LCM to both this and this. So here, this cancels this, leaving us with minus 1. Then minus this over this. Remember that cos x over sine x is cot x. But they are carrying square, so it's going to be cot squared x. Sorry. Yes, cos x over sine x is 1 over tan x, which is cot squared x minus cot squared x. You see? So that when you also say that if you differentiate cot x, you can also have minus 1 minus cot squared x. So these are the two answers that you can present whenever you are asked to differentiate cot x. And that is how it is being put on our table. So at this point, we have been able to show those things we have on the table and how their derivative was gotten. So then we'll move to case 1.2 now, still under trigonometry. Okay, looking closely at the board for case 1.2, we are still differentiating general exponential, general trigonometric function. But if you observe, the questions that are here are more developed than the first one. Now we have to differentiate sine 2x cos x plus 1 over x minus 1, sine x cos x, and this. So we are going to pick them one by one, and we are going to do them. So let me pick from here. The number one, I want to differentiate sine 2x. Y equals to sine 2x. Now, one thing I must make us understand here is that trig functions are subject to chain rules. Trig functions are subject to chain rules. Hence, they will be differentiated accordingly. Now, when you say you want to use chain rule, remember in our lesson 1, when you are dealing with chain rule, somebody must be a u, then the question will be rephrased. Then when the question is being rephrased, then the solution becomes dy du times du dx, or you can also call it du dx times dy du. Remember we said multiplication is commutative. So whichever one that comes first does not really matter. So let's see solution here. I will say let u be equals to 2x. Yes, this 2x, whatever the trig person is carrying that makes it a function, will always be our u. You see how I selected my u? So my du over dx. If I differentiate 2x, I have 2. Okay? Now once I have selected my u, because I'm dealing with it as a chain function. So once I've called this guy u and I've gotten my du dx, the question will change. I will now say, therefore, y becomes sine u. This is what I mean by the question will change. Then looking at the question, I have a y, I have a u. So I'm going to have my dy over du. So if I differentiate sine u, I have cos u. So my dy dx afterwards, the y over dx is du dx times the y du. And looking at what I have on the board already, I have my du dx, I have my dy du. So I'm just going to multiply the outcome together. So I'm going to be having 2 times cos u. So this will give me 2 times cos u, which will give me 2 cos u. But then we are going to return back the value of u, which is 2x. Therefore, the y over dx here finally becomes 2 cos. Instead of writing u now, you write 2x. And that becomes the answer for our question number 1. So if I differentiate sine 2x, I will have 2 cos 2x. So that is that. So we move to the other one, cos x plus 1 over x minus 1. But then there is something I want us to observe here. I'm still on this. If I have that y is equals to sine 2x, that is a very good shortcut. If you are good at differentiating functions, you have this shortcut to learn. What am I saying here? Excuse me. Sine 2x. 2x is a function here. So what I'm going to do is, I will differentiate 2x, I have 2. The person left here now is just the trig person, which is sine. Differentiate sine, I have cos. Then bring back 2x, and that is my final answer. I repeat, differentiate 2x, I have 2. Differentiate sine, not sine 2x now. Sine, I have cos. If you differentiate sine x, you have cos x. If you differentiate sine, you have cos, not cos, okay? So sine brought me cos. Always remember to return back your what? Your 2x. That is whatever function is here, and that is your final answer. That is what we call the short method for it. Otherwise, you use the normal method, which we have just listed in the first solving. So I move to the second one. Here I have cos into x plus 1 over x minus 1. And I'm asked to differentiate this. Yes, if I want to use my short method, I will just take this x plus 1 over x minus 1 and go and differentiate it somewhere. And once I get the derivative, then I'm there. So let's try that now. Let's imagine that in a question you were given that y equals to x plus 1 over x minus 1. So you are asked to find the derivative. So remember that this becomes your u, this becomes your v. So you are going to, the dy over dx here becomes v du minus u dv over v squared. Remember that? So my u is x plus 1. So that my du will give me what? If I differentiate x plus 1, I have 1. My v is x minus 1, which if I differentiate my dv, I will get also 1. So arranging it this way, I'm going to be having v, which is x minus 1, into du, which is 1 minus x plus 1 into 1 over x minus 1 all squared. That is going to be my v du minus u dv over v squared. Now, simplifying further, this times this will give me x minus 1, then minus x plus 1 times this will give me minus x minus 1 over x minus 1 all squared. Now, looking at this, you see that this is plus x, this is minus x. Minus 1 will produce us minus 2 over x minus 1 all squared. So what we are having here now is that if you differentiate this, you are going to have this. So bringing this knowledge back to here, so my dy over dx, if I differentiate this, I will have this. So I have minus 2 over x minus 1 all squared. Differentiate cos, you have minus sine. You get that? Then you return back this x plus 1 over x minus 1. That is the shortcut solution I showed us. Differentiate this, you have this. Differentiate this, you have this. Then bring back this. At that point, I'm going to be having minus becomes plus 2 over x minus 1 all squared sine x plus 1 over x minus 1. And that is the final answer. If you differentiate this, you are going to be having this. So what is there is, can you differentiate the function which the trig person is carrying? If you want to do it the other way, in this case, you say, let your u be this. Then if this becomes your u, then you are going to find the u, the x. And when you find the u, the x, you are going to be having this. Then the question will change to y equals to cos u. Then you have your du, the y du, which will give you minus sine u. Then you're going to multiply this times minus sine u. And if you do that, you will still arrive at this. You will still arrive at this. So that is for example 2 there. So we move to example 3. The leading algebraic sign here is multiplication. So my dy over dx will be u dv dx plus v du dx. Check our lesson 1 on this. Then here my u is the first guy, where my v is the second guy. So I will say let my u be equals to sine x, so that my du over dx becomes, if I differentiate sine x, I have cos x. Also, let my v be equals to cos x, so that if I have my dv over dx, I'm going to have it as minus sine x. Okay, so at this point, I'm going to be having my dy over dx to be equals to u sine x dv minus sine x plus v cos x over into du dx cos x. So this becomes, this times this minus sine squared x plus cos squared x. It gives me minus sine squared x plus cos squared x. Okay, yeah, you can leave your answer like this, but I want to use this medium to bring in some trig identities you need to know. You can still simplify this question, this answer, to a very simple form. Well, how do you do that? That is what I'm going to teach us now. Now, I haven't gotten this answer. This can serve as a final answer, but then it can be simplified further. Now, let's simplify it further. Now, I would like us to look up here. We have that sine squared x plus cos squared x equals to 1. We know that already. Therefore, if you make sine squared x out of the formula, you also have that sine squared x is equal as 1 minus cos squared x. So I can replace this sine squared x here with 1 minus cos squared x. Why? I'm getting this sine squared x equivalent for cos, so that these things will fill of cos squared x. So look at what I'm going to have here now. I'm going to have minus into, instead of writing sine squared x, I'm going to be writing 1 minus cos squared x. Okay, then plus cos squared x. Then at this point, minus times 1, we have minus 1 plus cos squared x plus cos squared x. Look at what I've got there. Minus 1 plus cos squared x. Now, cos squared x plus cos squared x will give me 2 cos squared x. So this becomes minus 1 plus 2 cos squared x. Now, this can also serve as final answer. Remember, we have 2 final answers here. 1. Now, we have this one 2. But then, can it be simplified further? Yes, because your final answer, if it's in an OBJ exam, it depends on where the examiner stopped. If the examiner did not stop here and stop here, if you cannot move yourself from here to here, you have problems trying to identify in the option the one that is your answer. So if he leaves it here, good, you see it in the option, you are good to go. If you can develop it here and see this in the option, you are good to go. This and this cannot be in the option at the same time. Now, can this be developed further? Yes. Now look at this trig identity 2, which you need to write down. Sine 2x, this is what we call double angle formula. Sine 2x is the same thing as 2 sine x cos x. Sine 2x is the same thing as 2 sine x cos x. Also, cos 2x is the same thing as 1 minus 2 sine squared x or 2 cos squared x minus 1. Any of them is the same thing as this. Now, look at this. 2 cos squared x minus 1. Look at what we have here. Do you know this can be written as writing the 2 cos squared x then minus 1? It's the same thing. You see, this is the same thing. So, and if we have this, they say it is equivalent to what? Cos 2x. Therefore, now, my dy over dx can also have a third answer called what? Cos 2x. This is answer number 3. So you see how I've dissolved this question sin x cos x, having 3 answers, 1, 2, and 3. What has helped me understand this is my trig identity. So now so far we have seen 3 trig identity. Sin squared x plus cos squared x is 1. Minus sin x minus cos x is minus 1. Sin squared x plus cos squared x is 1. So that sin squared x equals to 1 minus cos squared x. Also, you should know that cos squared x will also be 1 minus sin squared x. Okay? Also know that sin 2x is the same thing as 2 sin x cos x. And cos 2x is the same thing as 2 cos squared x minus 1, or 1 minus 2 sin squared x. Please, all this should be noted in your jotter while we continue. So we have just one more question, and we say goodbye to 1.2. And that question is y equals to 2x sine. You see it on the board. Let's quickly do that. Okay. Question number 4. Y equals to 2x sine x cubed plus 2 over x. Now, at this point, the leading algebraic sign here is product multiplication. So I'm going to use product rule. So here I'm going to be having let u equals to 2x, so that my du becomes, if I differentiate 2x, I will have 2. Then let v equals to sine x cubed plus 2 over x. Then I'm going to be having my dv over what? dx. Now, in this game now, sine of this, how do I get my dv dx? If I can differentiate this, I'll write it down. Differentiate sine, I write it down, bring back this. You should know that in this case, one thing that should be clear to you, you can simplify this further. What I mean that you can simplify this further is that, do you know that this x cubed plus 2 over x is the same thing as x cubed over x plus 2 over x. x cubed over x. Do you see that? 1 will cancel 1 here, leaving with x squared plus 2x raised power minus 1. So this can now be written as sine x squared plus 2x raised power minus 1. It is more simpler to simplify it, like to differentiate like this. So if I'm to differentiate this, if y is equals to x squared plus 2x raised power minus 1, my dy dx will produce, differentiate x squared, you have 2x plus, differentiate this, we have minus 2x minus 2. Hope you remember. Minus 1 drops to meet 2. Minus 1 times 2 will give us minus 2. Write down your x. Minus 1 minus 1 will give us minus 2. At this point, we have 2x. Plus times minus is minus 2 over x squared. So if I differentiate this, I'll be having this. If I differentiate this, I'll be having this. So at that point, I can now say dv dx is 2x minus 2 over x squared. So having that in mind, I will now use my dy dx One might say, can I use quotient rule here? Yes. Where you call this one u and you call this one v, you still arrive at the same answer. I just had to simplify it more further so it can take me to addition and subtraction rule. Then it is easier for me to move from there. So here now, our dy dx, since it's product rule, is u dv plus v du. So what is my u here? 2x into dv. 2x minus 2 over x squared, remember, plus, what is my v? My v is sine into x cubed plus 2 over x into du. Du is 2. So if I simplify that further, this times this will give me 4x squared minus 4x over x squared. 4x, 2 times 2, 4, x times x squared. Then 2x times 2, 4x over what? 1 times this will give me this, plus this times this will give me 2 sine x cubed plus 2 over x. Are you there? You see? So in this case, we can leave our answer like this. If you wish, you can simplify, but I think at this point, this is my final answer. Except you want to simplify further, you can start from here and simplify this further. So we are being able to start from number 1 and get to number 4 for case 1.2. Still under general trig function, but you see it's different from case 1.1. So all we just need to do is resolve these things on our own and master the steps. Remember, the foundation is still lesson 1. The foundation is still lesson 1. Always put your question on the comment section so that I can reply you wherever you are. Okay, so we move to the next one is case 1.3, still under trigonometry differences.